we're going to do this question 5. 5.1, we are asked to calculate the value of this expression here without the use of a calculator. So this problem here, you are supposed to get it right because you can simply punch a calculator and get the answer, right? But we are to solve it without the use of a calculator. So meaning, before you even solve, you can punch it in a calculator and see if the answer would be correct when you start solving, right? Okay, fine. So now let's start solving this problem. So we're having 1 minus 4 sinus squared of 15 degrees, right? What we need to note here is this is one of our double angle formulas. So if you use cos of 2x is going to give you 1 minus 2 sine of squared of x, right? And which can also be written as, so let me say, and can also be written as cos of 2x. So we transpose the one to the other side, it's equals to, so it's going to be minus 1, right? If you transpose the one to the other side, minus 1 is equals to minus 2 sine of 2x. So this is one of the double angle formula. So you can write it like this, hence I wrote 1, or you can write it like this, hence I wrote 2. So that's how we're going to approach this problem here. So meaning we're having 1 minus 4 sine squared 15, right? We can simply write as 1 minus 2 sine squared 15 minus 2 sine squared 15 degrees, right? So this portion here of the problem is this one here. It's similar to this, right? So which means instead of writing this, you're going to write this cos of 2x, right? So let's replace it. So it's going to be cos of 2x for this one, and then this expression here, which is minus 2 sine squared 15, is going to be this one, right? Which is cos of 2x minus 1. You see, it's similar to this one. So you're going to write cos of 2x minus 1. So that's how we can approach this problem. So now we're going to write this expression here now. We're going to say cos of 2 into, so instead of writing x, we're going to write the 15 degrees. So it's going to be 15 degrees. And then instead of writing this expression of minus 2 sine squared 15, we're going to write this one. So it's going to be plus cos of 2 into, so instead of writing x, we write 15 degrees minus 1. So now we've simplified our problem now into this expression here. So we're going to multiply the 2 inside here and also here. So we're going to have cos of 2 times 15 is going to give you 30. So it's 30 degrees plus cos of 30 degrees minus 1, right? So now cos of 30 degrees plus cos of 30 degrees minus 1. So the cos of 30 degrees will give you root of 3 over 2 if you know your special angles, plus root of 3 over 2 minus 1, right? So we're just going to add these and this. You're going to have 2 root of 3 over 2 minus 1. This root of this 2 will cancel out with this 2, and then you remain with root of 3 minus 1. So this is going to be your solution of this problem here, root of 3 minus 1. 5.2, we are asked to simplify the following without the use of a calculator. So with such problems, I really don't appreciate students who get it wrong, because you already know the answer before even starting to solve this problem, right? So what do I mean by that? If you have an expression without the values of x, you can simply punch it in your calculator and you will know the answer that you need to expect when you solve the problem. So you're just going to solve and make sure that you don't make mistakes. And if you made a mistake and it doesn't equals to the answer that you got, then you know you made a mistake somewhere, right? So with this one, because we're having this expression here and it has x values here, so you can't just punch it in your calculator, right? So what I suggest you do, just let x being equals to maybe any special angle, just use 30 degrees or 60 degrees, you know, or 90 degrees. Just use any angle actually, substitute it in where there's x, substitute it and just punch the whole problem inside your calculator. And the answer that you're supposed to get when you punch your calculator, you're supposed to get -1, right? So which means as you solve, you know very well that the answer that you need to get at the end is -1, right? Sometimes it doesn't necessarily mean it's -1. What do I mean by that? Let's say, for example, you have an expression of sine of x towards the end. Let's say towards the end, this is the answer, right? So which means you need to substitute this value, because you substituted this value initially and it gave you this -1. You're gonna substitute it again towards the end and say sine of 30 degrees and see what answer it's going to give you, right? And then that will tell you if the answer that you got initially and the answer that you're getting when you substitute this degree of 30 is the same, which means the solution of sine of x is correct. So I hope you understand what I mean by this. If you don't, please comment down below in the comment section and ask me. I will respond to your questions. But anyways, let's just solve this problem here and simplify it into the simplest form without the use of a calculator. So we're having root of 3 multiplied by sine of x multiplied by sine of squared of 72 degrees plus sine of squared of 198 degrees multiplied by root of 3 multiplied by cos of x minus 90 degrees. Then we divide by 10 of 120 degrees multiplied by sine of x, right? So what I can see in this problem here is we can eliminate sine of x. If you look here, there's sine of x, and this expression here can change into sine of x. What do I mean by that? Cos of x minus 90 degrees, we can write it as cos of, so we want to write it as 90 minus x, right? Which means we have to put a negative here, right? So we know a cos of a negative is actually positive, right? So we'll simply have cos of 90 degrees minus x, and this one here, because it's cos of 90, it's going to change to sine, and it's in the first quadrant, it's 90 minus x, so it's going to be sine of x. So this expression here is just going to change into sine of x. So now we know if we replace it with sine of x, we're just going to say root of 3 multiplied by sine of x multiplied by sine of squared of 72 degrees plus sine of squared of 198 degrees multiplied by root of 3 multiplied by sine of x, right? Divide by sine of x multiplied by 10 of 120 degrees. So let's factorize this sine of x and just eliminate it from this expression here. So we're going to have sine of x into the root of 3 multiplied by sine of squared of 72 degrees plus sine of squared of 198 degrees multiplied by root of 3, right? And then we divide by sine of x multiplied by 10 of 120 degrees. So the sine of x will divide out, then we remain with this other expression here. So another thing is, if you're having tan of 120 degrees, so if you reduce it, it's going to be tan of 180 degrees minus what? Minus 45 degrees, right? So another thing we have, so another thing that we need to note now is we're having tan of 120 degrees here at the bottom. So if we were to reduce this problem here, if you have tan of 120 degrees is equals to tan of 180 degrees minus 60 degrees, right? And you have tan, so because this is in the second quadrant where sine is the one that is positive, so it's going to be negative tan of 60 degrees. So if you know your special angles, negative tan of 60 degrees is equals to negative root of 3, right? So that is the solution. So now we know that the solution of tan of 120 degrees is actually negative root of 3, right? So what we need to do now is we need to eliminate this root of 3 because it's common in most of this part of this problem, right? So we're just going to first put this root of 3 instead of tan of 120. So you're going to say root of 3 multiplied by sine of square root of 72 degrees plus sine of square root of 198 degrees multiplied by root of 3, right? Divide by root of 3, which is negative. This is what we got here. Then let's factorize this root of 3 and eliminate it. So root of 3 into sine of square root of 72 degrees plus sine of square root of 198 divide by negative root of 3. Then this root of 3 will cancel out, so we'll remain with negative. So it's going to be sine of square root of 72 degrees plus sine of square root of 198 degrees divide by negative 1, right? So now what we need to do is this: we need to reduce both the sine of 72 degrees and the sine of 198 degrees. So to reduce this problem, we need to reduce it into let me just say the same angle. For example, we have sine of square root of 72 degrees, right? To reduce this, we'll simply say sine of we can use 90 degrees, right? 90 degrees minus 18 degrees, and then it's squared, don't forget. So 90 degrees minus 18 degrees is going to give you cos, because this is a sine, so it's going to change to cos of 18 degrees. Why the cos is positive? Because it's the 90 minus 18 degrees is in the first quadrant. Then we reduce the sine of square root of 198 degrees, which is equal to sine of square root of we're going to use 180 here, so it's going to be 180 plus 18 degrees. It's going to give you 198, right? So this is in the third quadrant where only tan is positive, right? It's here in the third quadrant, so meaning that the sine is going to be negative. It's going to be sine of 18 degrees, but it's going to be negative, so it's going to be negative angle. So you're going to have sine of 18 degrees, but it's negative, but you know that this thing is to the power squared, this squared here, meaning that it's going to be positive sine of 18 degrees. So this would be your answer for this expression here. So in replace of this sine of square root of 72, you're going to write this cos of 18 degrees, but remember that it is squared. I forgot to put, because it's squared here, it's going to be squared even here. Even here it's going to be squared because these two, it's outside, the power will multiply any power that it finds inside. So meaning now that instead of writing sine of square root of 72 degrees, you're going to write cos of square root of 18 degrees, and instead of writing sine of square root of 198 degrees, you're going to write sine of square root of 18 degrees. So let's write that out. So here we're going to write this, so it's going to be let me write it in black. So it's going to be cos squared 18 degrees plus sine squared 18 degrees divide by negative 1, right? So what you need to note now is this expression here at the top is the same as having sine squared x plus cos squared x. It's the same expression, which is equals to 1, right? So this expression is equals to 1. So which means the same thing applies with this one here, because it's sine squared 18 cos squared 18, which is equals to 1. So you're just going to say the top is 1, the bottom is minus 1. So the solution is minus 1. So this is the solution of the problem here. We're having 6 sine of x cos of x plus 3 cos of x minus 4 sine squared x minus 2 sine x equals to 0, right? So for us to solve for x, we need to first collect the like terms. If let's say we consider cos of x being the like term of this one, and then this sine of x being the like term of this one, so we solve them separately. So meaning that if this cos is the like term of this, which means this 3 is also a like term here, so we're just going to factorize those two first. So you're going to have 3 cos of x into, so what will remain is 2 sine of x plus the 1, because this expression here is this one, and then we have negative, which is this negative here. The like term is going to be this 2 sine of x, so it's going to be 2 sine of x into, so here it's just going to write the 2 sine of x because this is sine squared, and then we say plus 1 because this expression here is the same as this one, equals to 0. So what I need you to note is that what's inside is the same. So this expression here and this expression are the same, so we're just going to write them as 1. So we're just going to say 2 sine of x plus 1. So this is just going to be one expression, and then you're just going to put this one on its own bracket. So it's going to be 3 cos of x minus 2 sine of x, right, equals to 0. So now we have this expression here. Remember, we want to solve for x, so meaning this first expression, remember, we want to solve for x, so this first expression here, we're going to say 2 sine of x plus 1 is equals to 0, or 3 cos of x minus 2 sine x equals to 0, right? So we're going to transpose this one to the other side. You have 2 sine of x equals to minus 1, or here we could just going to transpose the minus 2 sine of x, going to be 3 cos of x equals to 2 sine of x, right? And then here we divide by 2 both sides, so you have sine of x equals to minus 1 over 2, or here we're just going to divide by sine, so here we're just going to divide by cos, right? Divide by cos of x, divide by cos of x will remain with 3 equals to 2 tan of x, because sine of x over cos of x is tan of x. And then remember, we want to solve for x, so we divide by 2, so we have 3 over 2 is equals to tan of x. So now we're having these two here, we still haven't solved our problem. Remember, we have to solve for x. So to solve for x for this expression here, we're just going to find the inverse. So it's going to be x equals to sine of to the power minus 1 of minus 1 over 2, or this expression here we're going to divide by tan, so it's going to be x is equals to tan of 3 over 2. So remember, this sign here, it's negative, here it's negative, but I want you to punch a positive. Don't put the negative in your calculator. So what I want you to define this negative as is it will tell you where sine is negative, because this expression is sine and we are having a negative number here. Where is sine negative? It's negative here in the third quadrant and the fourth quadrant. So those are your angles that you're going to use in the third and fourth quadrant. What do I mean by that? Theta plus 180 degrees is what you're going to use, or theta or you're going to use 360 degrees minus theta. So these are the angles you're going to use for this expression, because that's where your sine is negative, right? So but before we do that, let's first find the reference angle for this one. So the reference angle is going to be x equals to, so sine of 1 over 2 is going to be 30 degrees, right? So this is going to be your reference angle, right? And then here arctan of 3 over 2 is going to give you 56 point, so it's going to be x equals to 56.31 degrees, right? So this is going to be your reference angle. So please note that the reason why we're going to continue to find other values of x is because in this problem you are not given a restriction, so we're just going to continue until we finish. So as I said, these are the angles you're going to use: 180 plus theta and 360 minus theta. of which your theta in this case is going to be your 30 degrees, which is your reference angle. So x will simply be equals to that 180 degrees plus theta, which is equals to 180 degrees plus the 30 degrees, right? So your x value in this case is going to be 210 degrees plus 360 degrees of k, right? So this is the first solution, and then the second solution is this one. You're just going to use this one. We're going to say x is equals to, so you're going to write your 360 degrees minus theta, which is actually 360 degrees minus your reference angle of 30 degrees. So your x value is going to be 330 degrees plus 360 degrees of k. So this is your solution of x for this side of the problem. So now coming to this one where the reference angle is 56.31, how do we find these angles here? Theta plus 180, whatever. So we look at our tan. So our tan in this case is tan, and it has a positive value of 3/2, right? So where is tan positive? So you go to your Cartesian plane. It's positive here in the first quadrant, it's positive here in the third quadrant. So here the angle is 180 degrees plus theta, right? And here it's 90 degrees minus theta, or 360 degrees plus theta. So those are the solutions that you are looking for, right? So what you're simply going to do is this. You're going to say, okay, fine, I'm going to use 180 degrees plus theta, right? So meaning it's going to be x being equals to 180 degrees plus theta, of which your theta in this case is 56.31. So it's 180 degrees plus 56.31 degrees. So your solution of x for this problem here is So your solution of x is going to be 236.31 degrees, or another solution is going to be equals to your 90 degrees minus theta, right? Which is in the first quadrant. So x is equals to 90 degrees minus 56.31 degrees. So you're going to get 33.69 degrees. So these are your solutions of x. It's going to be this one here, and so you're going to say plus 180 degrees of k, because tan has a period of 180, so you're going to use 180 plus 180 degrees of k. So these are your solutions of x. So now we're going to do 5.4, and we are asked to prove that the left hand side is equals to the right hand side. So to solve this problem, let's use the left hand side to prove that it's actually equals to the right hand side. So we're going to choose the left hand side. The left hand side that we just chose is 1 minus tan of a into brackets multiplied by cos of a over cos of 2a, right? So this is the left hand side, yeah? And the right hand side that we are trying to prove to be equal to is 1 over cos of a plus sine of a, right? So you're just going to use this left hand side to solve the problem. So what you're going to do is you're going to first change this tan into 1 minus sine of a over cos of a. So that's one of the identities, multiplied by cos of a over cos of 2a, right? What I need us to do is to solve this 1 minus sine of a over cos of a. So by actually finding the common denominator, which is cos of A, and we know this one is over 1. So 1 goes how many times into this one that can't be seen? Goes 1. So we have cos of A minus this cos goes once in cos, so you have minus sine of A. So this expression here, it's actually equals to this one here, right? And let's deal with this one here. So we have cos of A over cos of 2A. So if you write it, we're going to write cos of A over, so cos of 2A is the same as cos squared A minus sine squared A, right? So you're simply going to write that cos of squared A minus sine squared A, right? So now I've written two expressions, this one here and this one here. So let's multiply both, because this expression is equals to this one and this is equals to that one. So let's multiply these expressions. So we have cos of A minus sine of A divided by cos of A. So here we put brackets, multiply by cos of A divided by cos of squared A minus sine squared A, right? What we can see is that this cos of A will divide out with this cos of A, so you will remain with cos of A minus sine of A over cos squared A minus sine squared A, right? Another thing that I need you to know is that at the bottom, this is the difference of two squares, right? If maybe you have x squared minus y squared, to factorize this, you'll have x plus y and x minus y, right? So you're gonna do the same thing here to factorize. So you will have cos of A minus sine of A divide by cos of A, you put the bracket there, cos of A, and then here sine of A, and then here sine of A, and it's going to be plus and minus. So the minus will divide out with this minus, and then you'll remain with 1 over cos of A plus sine of A. So this is equals to the right hand side. So this is the right hand side, if you remember clearly. So therefore this confirms now that the left hand side is actually equals to the right hand side. So now we're going to do 5.5. We are given this sine of 2 theta is equals to k, and we are told that 2 theta lies between 0 degrees and 90 degrees. So we are already told that it's in the first quadrant. And 5.1, we are asked to find cos of 2 theta, right? So what we know is that we're having sine of 2 theta is equals to k, and we are told that 2 theta lies between 0 degrees and 90 degrees. So when we're given this expression here, you need to first draw it in your Cartesian plane, right? Because we are told that 2 theta lies in the first quadrant, so it's 2 theta, and because it's sine it's opposite over hypotenuse, right? So the opposite of these 2 theta, it's this one here, which is going to be equals to your k, and it's divided by 1, so meaning here it's going to be 1, which is your hypotenuse side, right? So if I write that 1 properly, so it's going to be 1. And then we want to find this side here. So to find this side, you're going to say r squared is equals to x squared plus y squared. Our r is 1, so it's going to be 1 squared equals to our x, we don't know, plus our y is k squared. So it's going to be 1 equals to x squared plus k squared. Transpose the k to the other side. X squared is equals to 1 minus k squared. Then you put your square roots. So x is equals to the root of 1 of the root of, so x is equals to the root of 1 minus k squared, right? So here it's going to be root of 1 minus k squared. So now we are asked to find cos of 2 theta, right? Which this is 2 theta, but cos is actually equals to adjacent side over hypotenuse, right? So what's the adjacent side? The adjacent side is this one here, which is root of 1 minus k squared, and the hypotenuse side is 1. So this would be the solution of this problem here. And then 5.5.2, we're given this expression as to solve by determining it in terms of k, right? So to solve this problem here, we're having sine of 2 theta over tan of theta, right? So to solve it, let's first expand this. So it's going to be 2 sine of theta cos of theta, right? If you know your double angle formulas, this is one of them, over tan of theta, right? And this is divide, so it means now sine, it means, so this means now 2 sine theta cos theta divided by tan theta, which is equal to 2 sine theta cos theta times 1 over tan theta, of which tan theta is equal to sine theta over cos theta. So it's going to be 2 sine theta cos theta divided by sine theta over cos theta, right? Which would be 2 sine theta cos theta multiplied by cos theta over sine theta. So this sign will cancel out. We have 2 cos theta, and cos theta is going to be cos squared theta, right? So this is the expression that we're getting here, right? But what you need to note is this one here. We said when you have cos of 2 theta in the previous question, it's equals to root of 1 minus k squared, right? And to change this, you know it's a double angle, so you can have cos squared theta minus 1 also equals to this expression of 1 minus k squared, right? Here it's 2, right? So it's 2 cos squared theta minus 1. And if we transpose this one to the other side, we'll have 2 cos squared theta is equals to root of 1 minus k squared plus 1. So if you have 2 cos squared theta, this is the solution that you'd be looking for, of which this is what we got here, 2 cos squared of theta. So which means the solution for that, it's this one here. So you're simply gonna write the root of 1 minus k squared plus 1. So this is the solution of this problem here.